Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering typology subject. So this today we will see the question bank of surface interaction and friction topic. So already we have studied about this surface interaction and friction theory part we have completed. So now again we will see what type of questions they will ask in examination. So we will once we review the tutorial question bank with solutions. So the topic is surface interaction and friction. So in this, the first question is explain the importance of tribology in industries. So very first module in our syllabus. So the tribology, the study of friction, wear and lubrication is crucial across various industries for several reasons. It is generally the tribology involves around these three only: friction, wear and lubrication part. The reduction of wear and tear. The first one is the reduction of wear and tear. The importance is the mission longevity. So proper understanding and application of tribological principles help in reducing wear and tear of mission components, thus extending their operational life. So by reducing the wear and tear of mission components, so you can extend the operational life. The maintenance cost is lower wear rates lead to reduced maintenance cost and less frequent replacement of parts. So the maintenance cost is lower wear rates lead to reduce the maintenance cost. If not properly lubricated or wear rate is very high, so then it leads to damage the component, damage the mission. Every time frequently have to replace the parts. So by applying these typological parameters, the wear rate and lubrication and reduce the friction techniques, to you can reduce the maintenance cost. Next, energy efficiency. So whenever the minimizing the friction through effective lubrication and surface engineering, energy losses in machinery are significantly reduced. This enhances the overall energy efficiency of industrial process. The operational reliability, performance consistency, tribology ensures that missions and components operate reliably and consistently, reducing the risk of unexpected failures. So one is the energy efficiency. By reducing the friction, you can improve the energy efficiency. The overall energy efficiency of the industrial process you can improve. The operational reliability, the performance consistency, tribology ensures that emissions and components operate reliably and consistently, reducing the risk of unexpected failures. And safety, enhanced reliability directly contributes to safer working environments by minimizing the chances of accidents caused by mechanical failures. Sustainability, improved energy efficiency contributes to lower fuel consumption and reduced greenhouse gas emissions, aligning with the sustainability goals. So you can improve the sustainability and then safety and performance consistency you can maintain. And the cost saving point. So economic benefits. So lower maintenance, repair, and downtime cost results in significant economic benefits for industries. The productivity, efficient and reliable machinery leads to increased productivity and higher throughput. The product quality, one is the precision in manufacturing process. Tribology plays a main role in ensuring precision and quality of finished products by minimizing defects caused by friction and wear. The consistency means consistent mission performance ensures that products meet quality standards consistently, leading to higher customer satisfaction. So here, economic benefits. So the lower maintenance and the repair are down, minimizing the cost. It leads to improve the economic benefits for industries. Similarly, the productivity also will improve. The product quality also will improve. The innovation and development. So the innovation and development and this material science advances in tribology drive innovation in material science, leading to the development of new materials with better wear resistant and frictional properties. The technological advancements, tribological research leads to new technologies in lubrication and surface treatments, which can be applied across various sectors to improve performance and efficiency. So, the technology advancements, the tribological research leads to new technologies in lubrication and in surface treatments. It can leads to improve the performance and efficiency of the machine. Whereas in environmental impact condition, eco-friendly lubricants, the development of biodegradable and environmentally friendly lubricants reduces the environmental impact of industrial operations. The resource conservation by improving the durability of components, tribology helps in conserving raw materials and reducing waste. Next, key industry applications. So one is automotive. In automotive sector, the tribology is essential in designing and maintaining engines and transmissions and other moving parts to improve fuel efficiency and reduce emissions. Similarly, the aerospace industry, so high performance lubricants and advanced materials are critical for the reliability and safety of aircraft components. The manufacturing tribological principles are applied to ensure the smooth operation of machinery, reduce downtime, and improve product quality. So the industry application, the automotive sector, the tribology is very essential in designing and maintaining engines. Similarly, in case of manufacturing sector, the tribology principles are applied to ensure the smooth operation of the machinery, reduce downtime, improve product quality. So whenever you applied these friction and wear or lubrication treatments to the machineries, the industries, it can leads to improve the life, improve the product quality, and also possible to ensure the smooth operation of machinery. The energy, in the energy sector, tribology helps in maintaining the efficiency and the reliability of turbines, pumps, and other critical equipment. So next question is describe briefly surface topography and its applications. So what is this surface topography and what are the applications of surface topography in tribology? The surface topography refers to the detailed surface features of a material or object, including its structure, roughness, and pattern. It is characterized by the three-dimensional geometry of the surface, encompassing aspects like peaks, valleys, and the spatial distribution of these features. The surface topography is typically measured using various techniques such as profilometry, atomic force microscopy, and scanning electron microscope. So, the surface topography refers to the detailed surface features of the material. So, what are the features having that material or object? It gives full information, including its surface roughness values. So that this topography is typically measured using various techniques such as profilometry, atomic force microscopy, AFM, and scanning electron microscopy (SEM) measurement techniques. So, applications of surface topography. One is manufacturing and quality control. The surface roughness, assessing the roughness of surfaces is crucial for ensuring the quality and the functionality of manufactured parts, especially in precision engineering sectors like aerospace, automotive, and medical devices. The machining process, monitoring surface topography helps in optimizing machining process, grinding, milling, turning to achieve desired surface finishes and improve tool life. So the applications in manufacturing sectors. So optimizing the total entire machining process, whatever operations are there, operations required to complete the product. That is maybe it may be grinding or milling or machining or turning, drilling to achieve these desired surface finishes to improve the tool life. Next, tribology. The friction and wear. The interaction between surfaces in contact is heavily influenced by their topography. Understanding and controlling surface topography can help reduce friction and wear in mechanical systems, enhancing performance and longevity. The lubrication, the surface texture uh, plays a significant role in the formation and maintenance of lubricating films. The proper surface topography ensures effective lubrication, reducing energy losses and wear. Next, material science. In these coatings and treatments, the fracture and fatigue, the material comes under material science. The surface topography analysis is essential for evaluating the effectiveness of coatings and surface treatments. It helps in designing surfaces with specific properties such as enhanced hardness, corrosion resistance, or hydrophobicity. The fatigue and fracture The fatigue and fracture case surface features can influence the initiation and propagation of cracks. The studying surface topography helps in understanding and mitigating fatigue and fracture in materials. So, these coatings and treatments helps in designing the surfaces with specific properties. So, what are the mechanical properties? Hardness, toughness, and ductility, malleability, corrosion resistance, or hydrophobic. So, to enhance these properties, you have to apply the coatings and other treatments. The fatigue and fracture, the fatigue property already you know. So, whenever the component is subjected to cyclic load, so after certain number of cycles, the component will fail due to the low yield strength. So the before studying the surface topography of the material or object, you can avoid this type of uh, failures, the fatigue or fracture failures. So understanding and mitigating the fatigue and fracture. Next, biomedical engineering, implants and prosthetics. The surface topography of biomedical implants, that is dental, orthopedic, affects their integration with the biological tissues. The optimizing surface features can improve biocompatibility and osseointegration. So the drug delivery is controlled drug delivery systems. Surface topography can be engineered to regulate the release rates of drugs from implantable devices or coatings. In the case of biomedical engineering, uh, control the drug delivery systems. So, the study of surface topography, it leads to regulate the release rates of the drugs. Similarly, the implants and prosthetics. So, you can improve the biocompatibility. Next, electronics and semiconductor industry. In electronics and semiconductor industry, the importance of this topography, the microelectronics, the performance of microelectronics components depends on the precision of their surface features. The surface topography analysis ensures the quality and the reliability of these components. The solar cells, surface structuring of solar cells can enhance light absorption, thereby improving their efficiency. In optics case, the optical components, the surface finish of lenses, and the mirrors, and other optical components affects their performance. The high precision surface topography measurement ensures optimal optical properties. Anti-reflective coatings, the surface structuring can be used to develop anti-reflective coatings, improving the performance of optical devices. So next, geology and earth sciences. Terrain analysis and the erosion and weathering. So you can improve the by studying the surface topography, you can improve the geology and earth science environmental conditions. You can monitor the geology and environmental conditions. The surface topography is used to studying the geological features of terrain, helping in applications like mining, land use planning, and environmental monitoring. The erosion and weathering, analyzing the surface features of rocks and soils, helps in understanding erosion and weathering process. So the measurement techniques are profilometry. So this is one measurement technique. It measures surface roughness and structure by moving a stylus over the surface. The atomic force microscopy, that is AFM, provides high resolution topographic maps of surfaces at the nanoscale. The scanning electron microscopy, that is SEM, offers detailed images of surface features with high magnification. Next, interferometry uses the interference of light waves to measure the surface topography with high precision. So these are the measurement techniques. So detailed the measurement process we will see in coming up sessions. Let's explain any two surface topography measurement techniques. Next question. So this one is this measurement technique, topography measurement technique related to the previous slide. So already we have seen here different types of techniques: profilometry, atomic force microscopy, AFM, and SEM, and interferometry. So here, any two type of surface topography techniques you have to explain. So one is profilometry. Take this profilometry technique. So what is the principle? So here the major principle in this case is it measures the surface profile by moving a stylus or probe across the surface of a sample. So whatever is surface, you want to measure the topography properties. So the surface profile by moving a stylus or probe across the surface. The vertical displacement of the stylus as it encounters surface features is recorded to generate a detailed topographic map. Next types. The contact profilometry. Other type, two types are there in a profilometry. The contact profilometry uses a physical stylus that contacts the surface. As the stylus moves, vertical deflections caused by surface features are measured. So non-contact profilometry uses optical methods such as laser or white light interferometry to measure the surface profile without physically touching it. So in this is the difference between this contact profilometry and non-contact. Such as the laser or white light interferometry, in this case, the surface profile without touching the physical surface. The applications are: one is manufacturing, material science, and semiconductor industry. In manufacturing, ensures the quality and precision of machine parts by measuring surface roughness and texture. The material science analyzes coatings and surface treatments to ensure they meet required specifications. The semiconductor industry measures the topography of vapors and microelectronic components. Next, what are the advantages of this technique? Advantages and disadvantages. One is high precision, versatility, and detailed profiles. So the high precision means provides accurate measurements of surface features. The versatility can be used for a wide range of materials and surface types. The detailed profiles generates detailed surface profiles useful for various analysis. The contact methods are by damage soft or delicate surfaces. Speed can be relatively slow or large surfaces. So these are the disadvantages. One is contact methods, they damage the delicate surfaces, and one more thing is relatively slow for large surfaces. You can measure only small surfaces. So these are the advantages. Disadvantages. Advantages are there. The high precision, versatility, and the detailed profiles also you can extract. Next, second method is atomic force microscopy. So that is called as AFM. The principle is AFM measures surface topography by scanning a sharp probe, that is cantilever, over the surface. The probe interacts with the surface at an atomic level, and the deflections of the cantilever are measured to generate a topographic map. The AFM operates in different modes, including contact mode, non-contact mode, and tapping mode. So mainly it measures the surface topography by scanning a sharp probe, the cantilever over the surface. So in this operation, it operates in different modes. So one is including contact mode and non-contact and tapping mode. So what are the modes? One is contact mode, non-contact mode, and tapping mode. In contact mode, the probe makes direct contact with the surface, the measuring deflections caused by surface features. The non-contact mode, the probe hovers just above the surface, detecting forces between the probe and surface atoms. The tapping mode is the probe intermittently touches the surface, reducing damage to soft materials. The applications are nanotechnology. The measures surface features at the nanoscale, essential for nanomaterial characterization. The biological sciences analyzes the topography of biological samples, such as cells and biomolecules. The materials science studies surface properties and structures of advanced materials, including polymers and composites. So these are the applications of these two techniques. The advantages are high resolution and versatility and minimal sample preparation. So advantages are provides atomic or near atomic resolution, enabling detailed surface characterization, and then can measure a wide range of samples, including hard and soft materials, requires little to no sample preparation. Next, disadvantages. Slow scanning. The scanning large areas can be time consuming. The surface damage. The probe can potentially damage soft or delicate surfaces, especially in contact mode. The complexity requires specialized knowledge and training to operate and interpret results. These are the advantages. The disadvantages: slow scanning, surface damage, and complexity. So these are the references I have taken. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.